Hey everybody! In last week's video, we began our R Winter series by setting up our R Studio environment, covering basic programming syntax, and creating one-dimensional arrays called vectors. In today's video, we'll be using these concepts to help us understand matrices in R. In R, a matrix is a collection of elements of the same data type, numeric, character, or logical, arranged into a fixed two-dimensional array with a certain number of rows and columns. You can construct a matrix in R with the matrix function, which includes the following arguments. The first component refers to the collection of elements that will be arranged in the matrix. You could have also written out a full vector in that area, like so, using the combine class, but the previous example demonstrates a shortcut that can be used for numeric vectors. The argument by row indicates that the matrix is filled by the rows. If we set by row to false, we see how the matrix is now filled by columns instead. Here we can see how the shape of the matrices change depending on the value of this argument. Finally, the last component of the matrix function delineates how many rows are used. Note, though, that we cannot change the number of rows to a number that is not divisible by the amount of elements we have in our matrix. For example, changing n row to 5 will showcase the following error, because the length of our data, 24, is not a multiple of the number of rows. Here we see more examples of how the matrix can contain other element values besides numbers, including logicals and characters. Note, though, that while we can create and output each of these matrices as is, we can also save these matrix values to a variable, using the definitions we learned in the previous video. We can also name the rows and columns of our two-dimensional matrix as we had seen with our one-dimensional vectors. Let's say we want to create a matrix that compares the number of US civilians employed in different STEM and STEM-related fields. Last video, we just created a vector that detailed the amount of people that have computer occupations. With the matrix, we can expand this to look at other occupations and the difference in the amount of women and men employed in such fields. For our matrix construction, let's say we want to compare the difference between male and female employees in computer, life sciences, and physical sciences occupations. This is the data given to us by the U.S. Census Bureau from 2019. First, let's create a numeric matrix that includes these statistics. If we wanted the occupations to be listed in the columns and the employee's sex in rows, we would set the by row argument to true to organize by occupations, and set n row to 2 to have 2 rows for each sex. Now, when setting the names for the rows and columns, we use the call names functions to create different occupations, and the row names function delineates the male and female section. Besides making the information stored within a matrix clearer, assigning names can also allow for us to call on specific elements within the matrix, similar to what we saw with vectors last time. Using square brackets, we can call in the value of female employees in computer occupations like so, taking care to put the row value before the columns. If we want to print out all the female values for each occupation, we can use a blank space instead of specifying the computer column as seen here, and vice versa, to see all the values in the computer column without specifying the female row. Similar to vectors, if you don't have a name defined for these matrix positions, you can always use the row and column number to determine that position. For example, female is the second row and computers is the first column, so calling STEM occupations matrix of 2, 1 will output the same thing as calling the name of those positions. Likewise, mirroring what we saw with vectors, the standard arithmetic operators like plus, minus, divide, multiply, etc., work in an element-wise way on matrices in R. For example, if we divided STEM occupations matrix by 1000, each numeric element of the matrix would be divided by 1000. Similarly, if we did an arithmetic operation involving two matrices, the result would be the inputted operation with the respective elements of each matrix, as shown through these examples. I hope this video helped you to provide an introduction to matrices in R, from creating them for our own programs to manipulating their elements for each specific purpose. Next week, we will learn about other data types that we can use in our R programs to represent even larger sets of data with more diverse data types, such as through data frames and lists.